Hi, Integrated Math 1. Welcome to lesson 4.2.2a. Before we get into today's lesson, I do have a tiny little warm-up for you to do. You are going to want a calculator. I just want you, and you have like 4 of these on the page, on page 73. I just want you to do number 2. You can do all of them if you like. I just want number 2. I would like you to convert the ratio 3/8 into a percent. Hit pause. Work that out. Hit play when you're ready to check your work. So I grabbed a calculator. And the first thing I did is I realized that a ratio is just a division problem. So I just take my calculator and I did 3 divided by 8. Hooray! And that gave me a decimal of 0.375. Now, the only thing is, I don't want a decimal. I want a percent. Please remember that to turn it into a percent, that means you need to take this little bad boy here. To become a percent, you need to multiply it by 100. All right? So we're going to multiply by 100. Actually, wow, I'm already making things weird. We're going to multiply by 100. I want my pen back. So times 100. So I'm going to take my lovely calculator here on my 0.375. I'm going to times by 100. And that gives me 37.5%. Don't forget to put your percent sign on the end of it. Now, there's a reason why I made you do this. Of course there is. Today, we're going to be talking about relative frequency distributions. All right? Taking it a little further. We've done frequency distributions. We did marginal frequency distributions where we added up all of our bits. Now we're going to talk about a relative frequency distribution. Today and tomorrow, that's what we're going to be taking a look at. So our goals for the next 2 days here, we're going to construct and interpret relative frequency distribution and marginal relative frequency distributions, again displayed in two-way tables for categorical data. We did that before. We had our two-way tables, right? We had variable, we had everything split up into groups. Still going to be doing that. We're just going to push it a little further now. And again, we're going to analyze and use our marginal relative frequency distributions to make decisions for a problem situation. Here's my data, I have it all organized, I got all my bits. What choices should I be making? So our key terms as we go into this today is, of course, relative frequency distribution. We've done frequency distributions. Now we're going to go into relative frequency distributions. Marginal relative frequency distributions. We've done marginal frequency distributions. Now we're going to do marginal relative frequency distributions. We're just adding an extra word, and really that just means one extra step. So you have organized and analyzed data using marginal frequency distribution tables, right? We put them all into our groups, and then we added up each group, and we added up each group, and then we made sure that we had our total and that everything matched up nicely, right? We've done that already. But how can you use percents to analyze the same data set? Now instead of just raw numbers, what if we used percents? So to get things started, we're on page 74. A sample of 9th and 10th graders, 10th grade students at Valley High School were surveyed about their favorite things to drink on a hot day. There were a total of 5 groups recorded for the variable favorite drink, including water, sports drinks, iced coffee, lemonade, and iced tea. The frequency distribution shows the results for the group lemonade. So here's my lemonade group. I don't have the whole table. I just got my lemonade group. 2 students used the table to make the following statements. Chris said 7% of 9th graders and 7% of 10th graders prefer lemonade. Brad said, hey, since 7 equals 7, the same percent of 9th and 10th graders prefer lemonade. Can you tell me why each student is incorrect? Hit pause, jot down your thoughts, hit play when you're ready to check your work. So first of all, these aren't percents, right? These are just 7 numbers, right? 7 9th graders said they preferred lemonade. 7 10th graders said they preferred lemonade. So already, Chris, it's not a percent. The number 7 represents the frequency and it represents the number of students that made that statement. It's not a percentage. Chris. Let's talk about Brad. Now, Brad says, all right, 7, So 7 ninth graders, 7 10th graders. So Brad says, hey, the same percent of 9th and 10th graders prefer lemonade. Yeah, Brad, I'm going to pull the brakes on that one. I don't know what this is as percent. I know 7 ninth graders said it, but I don't know how many 9th graders were surveyed. I know 7 10th graders said that they preferred lemonade, but I don't know how many 10th graders they asked. Brad. So Brad is incorrect because even though the frequencies are the same, the number of students in each grade level may not have been the same. Maybe I only asked 10 ninth graders, but I asked like 30 10th graders. That's not going to be the same percent, is it? So Brad, I know you had good intentions there, buddy, but we're going to work on that. So page 75. Let's get into this whole percent idea. The North Point Community Outreach Director wants to plan special summer activities for the members of North Point. And he selects a random sample of members of the community, and each of those members responds to his survey. Participants identify their age and then choose from the 4 given categories. And the response gathered from the survey are shown on this lovely table. So as we're doing this, just something to have in your head, is there an association between a person's age and their preferred activity? So here's the table. You have this in your book on page 75, which is very nice. Remember, we had age groups. So students age 18 years old and under, right? Younger people. Adults age 19 through 50 years old. That's my age range. Adults over 50 years old. That's not my age range. So these are our ages. Our 4 activities, we could choose from sports, movies, reading, or walking. And of course, this is a marginal frequency distribution table, so we also have all of the totals. So the total people who said each category, chose each category, the total people of each age that were surveyed, and then you can see the overall total in the corner over here. Oh, this is blank. There we go. So we did this before. We had a table like this last time, right? While the raw data provides some information, it's often more efficient to use percents when you're analyzing the data, right? We're trying to compare the different groups. This is called a relative frequency. So the relative frequencies of each data entry can provide that information. Like what percent of people said that, and then you can compare that percent to other groups. So we're relating the frequencies to each other. So representing the relative frequencies for your joint data, and when you display it in a 2-way table like this, is called a relative frequency distribution. So instead of just raw numbers like that's how many people said that, let's talk about the percent of people that said that, the percent of people that chose that. The relative frequency distribution provides the ratio of occurrences for each category to the total number of occurrences. And it makes it easier to directly check. Displaying the relative frequencies for the rows or columns is called a marginal frequency distribution. So the marginal, I'm losing words, the marginal relative frequency distribution, so many words. The marginal relative frequency distribution provides that ratio of total occurrences for each category to the total number of occurrences. So let me show you what I mean here. Here I have an empty table, and there's a reason. We had this table filled out earlier, right? On the page next door on page 75, you can see the total table, right? 20. In fact, I am going to write these numbers in real quick, and you'll see why in a little bit. But I'm going to leave myself some space because I'm going to do stuff to this numbers. So let me show you what I mean. 20 people, 18 years and under, said that they preferred sports, right? But if you recall, we had a total of 280 people who took the survey, right? If you included everybody, every group, everything everybody said, 280 people did the survey. So here's what we're going to do. We're going to create a relative frequency. So instead of just straight 20, I'm going to say 20 out of the 280 people chose sports. So 20 out of the 280 people were 18 years and old and under and chose sports. So I'm going to grab my calculator, just like with the warm-up. I'll do 20 divided by 280, and then I will multiply by 100, and it turns out I get about 7.1%. So of all the people surveyed, 7.1% were under 18 and preferred sports. You get the idea? So I want you to do that for every single box. It's not hard, but it's going to take you some time. So go ahead, hit pause, and do this. You're going to take every single one of those numbers and you're going to divide it by 280 and multiply by 100. For every single number, divide by 280, multiply by 100, give me the new percent. So go ahead, hit pause, fill it all in, and then hit play when you're ready to check your work. All right, I cheated. I'm not going to lie. So you've taken the time. You took every single number, divided it by 280, multiplied by 100, got all those percents. Here they are. So here they are. Here's all of our relative frequencies. Yay! So you did your marginal relative frequency distribution table. That's a mouthful. All right, and we have all of our percents. But look how easy it makes it to compare. Right? Now that we have all these percents, it's so easy to compare all the different things. By the way, did you notice I even did the percent down here? 280 people total divided by 280 people total gives me 100%. Yes, it does. So now this is making it so much easier to compare my data, isn't it? Now that I know how they all relate to each other. So use this lovely table. And on page 76 and 77, you've got 5 students, all right? And you can see some of them on page 76. You got to flip over, and some of them are on page 77. 5 students in Mr. Thomas's class made the given statements, and you can see thumbs ups and thumbs down on them. For each statement, explain why the student is correct or incorrect. And if the student is incorrect, can you tell what the correct statement should be? Go ahead, hit pause, jot down your thoughts for all 5 of these students, and then hit play when you're ready to check your work. So let's start off with Isaac. Isaac says 58.6% of participants in the survey prefer watching movies or reading in the hot weather. So here's movies, here's reading. I've got my 2% there. And sure enough, if I grab my calculator, 29.3% plus 28.9%, yeah, that's over 58%. That's a lot. Okay. So I'm going to say Isaac is correct because both watching movies and reading were preferred by 82 of the 280 participants, right? 80, I can't even see. Movies and reading. Oh, I should look at movies and reading. Yeah. So 82 plus 82, that's 164 people. If I divide that by 280, yeah, I get 58.6%. I think I was adding the wrong categories either. So these two right here, 29.3% and another 29.3%, puts us at 58.3%. So yeah. Shane says that 1.07% of adults over age 50 prefer walking in the hot weather. So here's my over 50 crowd. Here's my walking. Wait, he said 1.07? Shane's incorrect because 30 divided by 280 is equal to 0.107, but if you multiply by 100, that's 10.7%, not 1.07%. So the correct statement should be 10.7% of adults over age 50 prefer walking in hot weather. Marie, out of all survey participants that prefer playing sports in the hot weather, 7.1% of those are students age 18 years old and under. So let's see, we said that's wrong. Out of all the survey participants, I think it's about the way she worded it. 7.1% is not just based on the 18 years old and under crowd. It's based on everybody. So Marie's a little bit incorrect. Because 7.1% is based on the total number of survey participants, not just those who prefer playing sports in hot weather, right? So the correct statement should be that 7.1% of those surveyed are students age 18 years old and under who also prefer playing sports. So it's just the way she worded it. It's not 7% of the people who played sports. It's 7% of all of our participants are 18 years under who prefer to play sports. I know that sounds silly, but it kind of matters. Olivia. Olivia said more adults over 50 responded to the survey than any other age group. Well, if I look, my total number of adults over 50, that's only 32% of my peoples. So I've got 39% that were 19 to 50. So actually, the over 50 crowd was not my biggest group, was it? So Olivia's incorrect. The adults over age 50 had a percent of 32, but those 19 to 50 had a percent of 39.3. So the correct statement would be that more adults aged 19 through 50-year-olds responded to the survey than any other age group. That's actually our biggest age group. And now we have Aaron. Aaron says playing sports is the least popular activity in the hot weather according to the survey results. Well, let's look at our totals down below. I've got 28.9, 29.3, 29.3, 12.5. Aaron's right. Sports only got 12.5% of the total votes. That's the smallest percentage, which is fair. When it's hot, I don't want to be running around outside. It's sweaty and nasty. I don't want that. Just a few other little questions here on page 77. So I've got questions 3 and 4 and a couple more here. You can go ahead and answer these questions on page 77. Use your lovely frequency table. Hit pause, write out your answers, hit play when you're ready to check your work. So question number 3, which age group made up the smallest percent of people surveyed? Let's see, 32, 39, 20. Oh my goodness. Students age 18 years old and under were the smallest group of people surveyed. We only had 28.6% of them. Does there appear to be an association between age and preferred activity? I told you at the start of this activity to start thinking about that. And I don't know about you guys, but I did kind of notice a trend. I noticed that both movies and reading were preferred by the largest percent of people, right? Definitely 29.3%. Movies and reading seem to be most popular amongst all the age groups. But yeah, there's definitely an association between age, right? I mean, if we look at this, we can see that most of the adults 50 years and older, right? If you hit 50 and older, they definitely preferred reading. It's hot. They wanted to just chill and read a book. But if you look at your younger crowd, they preferred going to the movies. And that's even true. And even for 19 to 50-year-olds, like they liked going to the movies, but they also kind of preferred going walking. So most adults over 50 years preferred walking, while most adults 19 to 50 years old adults over 50 preferred reading, but most of the adults between 19 and 50 preferred walking. I like walking. And the group with the highest percentage for sports was definitely our 18 years old and younger crowd, right? Yeah. So not really surprised by that. And maybe you notice some other things too, and that's okay. As always, I hope you found this helpful. I hope you found this useful. If you've got questions or concerns, come talk to me, and I'll see you guys soon. Bye.